Hello, Namaste. Welcome back to the course on Geographic Information System. This is the last session on how we look at spatial analysis, wherein I would be speaking on advanced spatial analysis in this particular class. Also, I would give you some disadvantages or limitations that we are facing in today's GIS world. So, when we are looking at this as a scenario, we would also look at what are the basic limitations and how do you forego. So, probably at the end of this session I would also give you certain things that what should we look forward in terms of being a GIS user. So, that may be at the end of this course, but in today's class let us understand what do you mean by advanced spatial analysis, what are different tools in advanced spatial analysis. We have done some of these analysis before, but we have not already spoken it about as spatial analysis, but just spoke it about a specific tool. So, but we will speak each of these things as a tool, okay, and then we would look at the limitations part of it. So, as I rightly said, we would look at network operations, proximity operations, how do we do an interpolation, different methods in. I would give you a very basic methods and interpolations, not very advanced techniques, okay. GIS analysis models, what are different models of analysis, then looking at DTM, we have already spoken about what do you mean by a DTM, how it is very different from your DSM, then looking at tin model, the contour model, etc. Then problems in establishing GIS, that is the last topic that I would speak about in this particular class. And when we are looking at network operations, networks, it is a system of connected lines represented by a vector data, okay. When you see this particular point, this is a particular point where there is a starting point and there is an ending point. There as I spoke in the previous class, if you want to reach at a particular from a particular point to a particular destinations, there can be several routes. This can be a shortest route that you reach here, okay. There may be another route which is reaching here, there may be another route which is actually reaching at this point. So, there are different nodes, there are different stopping points, there are different ways of obstructions, etc. So, based on what is the best travel region, that is how you travel for your particular operation. That is what is basically the network operators, okay. So, it can actually help in determining the fastest route or shortest route, or even the resistance is entered as an attribute and route with least resistance is actually considered. Let's say that I am actually solving a problem of electrical issue in a particular building, okay. There are lot of wires that actually are moving out. So, now I have to look at which wire may have been damaged because of its life or its different issues that may occur. So, what I try to do is that I will find out how these lines are actually connected, where it is connected, okay, if there are obstructions in that region, or what is the kind of loading conditions in that particular lines, and what is the amount of load. So, once we have understood all of these things, probably we will be able to understand. So, if it was physically, then you would have to calculate each and everything separately and then combine it to using certain mathematical issues, then come up with a particular equation and then find out what may be a particular issue. But now I have a different layers. So, once I have created these different layers, which may not be an issue because most of the data is available, just creating a layer is not an issue. Once you have created the layer, then you overlay on it and you will say this particular line is actually as an issue, okay. It is as simple as this. That is how the network operations are done. Or another operation is shortest route that I explained in the previous class, okay. So, network operations are actually based on the continuous connected networks. So, always network operations are continuously connected. So, please keep this in mind. I have seen some people who try to put it on network operations where there are no connected entities, okay, or connected relations. So, unless it is connected network either through entity or a relation, you cannot do any kind of network operations. So, rules for displacement in a network. So, you should understand what are the different rules that you can have it on a network for understanding the displacement units. Definitions of units of measure, what kind of measurement you are trying to do. For example, I gave an issue of electrical loading and a road network. So, both units does not match each other. So, you have to maintain different units for different systems. So, please keep this in mind. Accumulation of attribute values due to displacements. There may be a large amount of displacement or the new replacement that would have been happened over a period of time. So, there may be a large number of attribute values. So, look at those attribute values and then do a network operation. Rules for manipulating attribute values. So, you should create your own rules to actually manipulate the attribute values. Okay. So, this is about the network operations. So, use that very carefully, where probably when we are looking at practical class, we will look at how we do a network operation. Okay. Then there is a proximity operation. So, proximity operations and spatial interpolations are very well known tools or systems in in any spatial GIS. So, GIS supports proximity operations in which new values are assigned to new points on the basis of value of the existing neighborhood points or observations. For example, you have 10 meteorological stations and you want to represent the entire what is the rainfall in the entire region. So, you collect all the 10 values from the 10 meteorological station. So, you apply a proximity analysis in terms of interpolation, any kind of interpolation that you may use. So, that depends on what kind of accuracy you need. So, based on that you will find out what is the rainfall in different regions, which means to say that you are trying to look at the proximity locations from that particular point meteorological stations to find out what is the value around that particular station. The procedures that it can be here is identify a base station. First thing is look at what is the base station. Okay. Then define a compute search area, then select and search of objects that can be there in that particular region. Once you have understood the objects that are there in that region, then look at the values that you will have to look at. It includes operations such as sum of all the values, average of values, the greatest of least values, any kind of operations that is dependent on the user to use such operations. I gave you an example of rainfall. So, if I want to look at the gradient of rainfall across that particular region where there is 10 meteorological station, probably I would look at interpolation of values with the neighboring objects. So, I know in between those stations what is the change of values that has happened, the gradient of change. So, that once you have the gradient of change and represent it as a thematic map, probably it is easier for anyone to understand what kind of analysis has been what kind of rainfall is there in that particular region. So, it may be useful in various kind of analysis. For example, someone is trying to relate vegetation with rainfall or different kinds of vegetation with rainfall. Okay. It may be evergreen forest, it may be coniferous forest, it may be just an open land. So, if you want to establish a relationship, the first thing that you will do is that you will collect the meteorological stations, then you have first you interpolate it and find out what is the region. So, you have let us say you have 2 or 3 catchments of that particular water body there. So, you have rainfall data, then you will find out what is the amount of water availability in that particular region, then you will find out what may be the amount of if there is vegetation, what may be the water availability in the summer season and what may be the water availability without vegetation or specific vegetation. So, that is how different kinds of analysis can be done. So, that is where your proximity analysis is essentially useful. Then you have statistical distribution of values, how these values are distributed statistically. So, that also can be done. So, everything, all kinds of analysis is dependent on a user. There is no fixed rules of using any kind of tool or analysis. So, it depends extremely on the way the user thinks. Okay. So, interpolation, when you are looking at interpolation, as I said, interpolation is a process of defining a function that takes a specified value at specified points. And when you are looking at mathematical part of it, extrapolation is a process of constructing new data points outside a discrete set of known points, and interpolation is creating a new set of data inside the set of known 2 discrete points. If there are 2 discrete points, if you are finding out a point here, then it is interpolation. Okay, in between. Extrapolation is outside these 2 points. Okay. So, when you are looking at it, the most easiest way, least computational way is using a nearest neighborhood. Then you have linear, bilinear, bicubic, spline. So, any kind of interpolations can be used in such analysis. And if you look at this, when I say nearest neighborhood, so you have the nearest value that is actually assigned to that particular. So, you let us say you have a neighborhood. So, you will look at which is the nearest value that actually matches to this particular point. So, nearest value is assigned to that particular point, whereas when you are looking at bilinear interpolation, it considers a closest 2 cross 2 neighborhood, which means a 4 neighborhood if it is an 8 pixel neighborhood. I am speaking about a raster data, okay, surrounding the any of the unknown pixel. Okay. So, now if it uses a 2 cross 2 neighborhood, which is a 4 neighborhood, okay, so it takes a weighted average of these 4 pixels, okay, at its final interpolated value. The results is smoother looking images than any of the nearest interpolation. So, this is more smoother, okay. And if someone has good computational capability, probably they look at cubic or bicubic. When I say cubic, it looks at 8 pixels around that particular point, okay. If there is a central raster value and you have a number of pixels that you are considering, so 8 directions is 8 pixels. So, you take in 8 pixels and you find out what is its name, what is the particular point. Based on, maybe you will sum it and then consider the mean of that value. So, you will you calculate the mean of that particular value, you will get the cubic interpolated value of a particular point, unknown point. Similarly, when you look at a bicubic, we look at a 4 cross 4 neighborhood. It is a 16 pixels that you consider around the particular point. So, since this is the distance we do not know based on unknown pixel, the closer pixels are given higher weights in terms of calculation, and as you wean away, it is a lower weights. Okay. So, bicubic produces noticeably sharper images than the previous two methods, and is perhaps the ideal combination of processing time and output quality. For this reason, it is a standard in many image editing programs. So, printer drivers and in-camera are interpolated. Okay. So, you have printer drivers is and in-camera drivers are more have been interpolated. Okay. Then there is something called as spline interpolation. So, it refers to instrument used normally in drafting. Many of the planners use spline interpolation, which is most probably the standard for planning activities. So, it is a thin flexible wooden or a plastic tool that is passed through a given data points and defines a smooth curve in between them. The physical spline minimizes the potential energy subject to interpolation constraints. The corresponding mathematical spline must have a continuous second derivative and satisfy the same interpolation constraint. So, it uses the second derivative value. The breakpoints of the spline are also referred to as knots. Okay. So, these are knots that you use. So, whatever I am showing here is actually a cubic spline. Okay. Now, when you are looking at different models in a GIS, there may be several models. For example, there is based on cartographic algebra, there is expert systems, there is linear combination. So, you can even look at certain articles, research articles recently, where expert systems are used for different kinds of analysis, GIS and analytical models. When you are looking at cartographic area, it is based on the assumption that a set of simple operations can be found and joined sequentially to form a complex model. Okay, which means you have a set of different models which have simple algebra, then combining it will form a complex model with a complex algebra. And then the process starts with existing set of attribute data stored in the tables. These are processed in a sequence of operations which produces a new column in the table. Then finally, these are compiled and can be used for various analysis. Then this is example of an thematic layer of ABC that are manipulated into a single layer and a one attribute table at the end to perform it as a model. So, you have a layer with attribute value, layer B with certain attribute value, layer C with attribute value. So, you perform certain analysis here, then once you have found out that analysis, then you will have the final layer which is actually interacting with which is actually containing all the attributes that you would have produced. Then you have an expert system. These are in which the analytical results are assessed automatically in terms of critical criteria entered as an ancillary information of attributes. So, you have attributes, you have a criteria, based on that you try to look at the expert system. And based on the criteria system, the very good well known expert system is analytical hierarchical process. So, if you want to look at this, probably the expert systems, if you look at any of the GIS papers, you can find out AHP is well known way of looking at how an expert system can be used as an expert. For example, when I say expert system, these are the values that are maybe from the expert surveys or expert opinions that you take in and create your own table listing, where you actually compare across variables. Once you compare across variables, you start defining it with weights, and once you have defined it weights, it automatically evaluates to give you a particular value. So, based on that value, if the value is less than 0.01 or 0.1, so normally it is considered to be analytically possible for any kind of analysis. So, this kind of using an expert system may be useful in when you are trying to use a huge number of variables in your particular analysis or different entities in your analysis. And the next kind of modeling may be using a digital terrain model. I have given you a good example of what you mean by a surface model and a terrain model. For example, here if I let us say I have an data that I have planimetric data that I have considered. So, now I can do any kind of analysis. For example, if I can do elevation modeling, I can look at contour modeling, I have volume modeling, shading and draping modeling, and all of these can be performed using these surfaces. When I look at DTM, digital terrain model, it is only the surface of the earth that is measured in this particular model. And when you look at the digital surface model, for here let us say that this is the surface of the earth that is being mentioned here. Okay. So, now this is this is a valley and this is a hill and this is a plain area. So, when you are looking at this, if you are if I want to mark it here, this is a hilly area, this is a plain area, and this is the valley, okay, whatever is the thing. Now, if you look at this, follow this blue line, that is representing the terrain, how the terrain of the earth's surface is there. So, without human interference, what kind of terrain of the earth's surface is there, that is exactly the digital terrain model. If with the interference of the human interference is there, or the natural way of development is there, what it may be a tree here, it may be houses that have been developed. So, if that is also used, then you try to find out what is on the surface. So, you get this kind of model like this. Let us say if there is a tree, it would have come something like this. So, that is nothing but a digital surface model. There are various ways of extracting a terrain model and a surface model. Probably if someone is interested, please explore how it is done. Okay. So, that is one of the well known research methods in various kinds of analysis, research inputs in various kinds of analysis that can be used. Then you have an elevation model. This is you have an elevation data that is stored maybe in random points. So, based on the computed weighted means of the surrounding points, using a closest point, you try to find out what is the greatest weight. So, nearing points are searched within that particular area, and you will find out what is a particular elevation at that particular point. So, that is a elevation model. Then you have a tin model. I have already explained the tin model previously, so I would not get into details of what do you mean by a tin model here. Then is the contour model. So, again the same thing I have spoke about in the previous sessions, maybe in the 5th week or 6th week. So, please refer to those sessions when you are looking at the contour model. So, I have spoke about both the disadvantages and advantages. So, you can probably refer there. And there is another model which is called a slope and slope direction model. So, this actually if you are looking at a hydrological application, this is extremely useful kind of model. It identifies the maximum rate of change and which is the direction of rate of change. That is what is important in a slope and a slope direction model. Any output slope grid can be calculated using the percentage slope or degree of slope. Okay. So, aspect or a slope direction identifies the down slope direction at the maximum rate of change in a value from each cell to its neighbors. For example, I am showing you this. This is one of those hydrological models that you can see. So, when you are looking at this, it is actually defining how the hydrological model is connected, how that particular drainage system is connected. So, this kind of analysis can be performed using this slope modeling. Then once these are the different advanced kind of analysis that you can do. Other than this, you have fuzzy analysis, you have different kinds of expert systems that you can utilize, you have artificial intelligence techniques that you can apply it on GIS. So, extreme number you whatever you think can be used in with GIS. Okay. But I would stop at this aspect so that you will be able to understand it. If someone wants to look at advanced part of it, probably you should look at some advanced GIS in terms of developing it. Now, let us look at what is a formal problem in establishing GIS. If you want to look at GIS as a establishing factor, what may be the issues? The first issue that you would come across is the ownership and the copyright. Okay. So, you would have heard about data rights. Okay. So, geographical data is always considered to be an intellectual production. Okay. So, it is regulated by IPs. So, when I say intellectual production, it is term used for devices whose value is actually not based on the ownership of a physical article, okay, but it can be a digital article. So, the ownership of such productions may be regulated through, it may be through pricing, or it may be through the licensing mechanism. The data can be also protected by any copyright law only if it fulfills the requirement of a national law. It can be protected on a national legislation on issues such as database protection and unfair competition. So, all of these are issues when you term of ownership, etc. When you look at geographical data, you have procurement from a single agency, or you have multiple stakeholders when you are actually procuring such data. So, if you have a single agency which you are trying to look at the geographic data who has a ownership, then you can easily get that ownership status. But if you have multiple stakeholders, then it is extremely complicated. That is where today's GIS data is actually failing the consumer or the user who really who has to consume this data for his or her daily related activities. Okay. So, when you look at the copyright laws that normally govern such digital data, you have the Berne Convention of 1951, which said which specified a common international regulations for protection of copyright. Okay. So, you have, and then you have an EU database directive that gives protection to sweat of the broad databases, where all data are registered or catalogued by one or the other mean. Then facts are normally not copyrighted under the copyright law, only the digital data is under the copyright law. Okay. The data that needs to have a necessary level of importance to be a copyright protected. So, you should understand that there are only certain data which are actually can be copyright protected. So, what is that data? Probably you can look at the Berne Convention entire report, or you have Indian rules also, wherein you can look at similar activities. The rule are similar for both data being produced in digital or analog form. Okay. Copying from one electrical storage to other in a is a reproduction under the copyright law. Okay. So, when you are actually reproducing it, you are supposed to either credit the author and also produce certain information from that author as necessary. So, copying a screen display is more of a problem, and is, but for example, if you see the very recent issue is that if you actually put in presentations online, okay, or maybe your videos online, people take a screenshot of that video and add it into their presentation. So, that is more a problem, that is really a problem. Okay. But now you have reverse image search where you can find out from where that screenshot has done, but it is really a problem in terms of copyright laws. So, be specifically careful. So, when you are producing data, you are governed under the copyright laws. So, sharing also has certain policies. Okay. For example, in USA the policies vary with states However, in UK the public sector claims the copyright. In Canada, you may have certain usage fees whenever charged whenever the value of a digitized data exceeds the incurred. I mean, if you have a digital data, the value of it is much higher than when it is incurred in acquisition and digitizing. Then you have to pay up some value as a fee in Canada. Whereas in India, we have several public entities providing data, but these are not on a unified framework. We do not have any value network, but we have a huge data set in India which is publicly available. Only thing is that we do not know exactly the source. Okay, but government is really doing excellent work in terms of developing a national data registry, so that the more of the spatial data is available to the user upfront. Okay, so you have cost recovery and pricing. I said the best way of maintaining the data is using the cost recovery and pricing. When I say data pricing, the pricing value must cover data establishment cost, storage cost and distribution cost. When I look at pricing, pricing depends on data quality and details, timeliness of data, completeness of data, topological continuity of data, user applicants who will use that particular data or use in certain applications. So, all of these things are considered when you are looking at pricing. Okay. So, it can be different for user categories. For example, in India the academic and the public sector are charged less, whereas the commercial users use the same piece of data, they buy it at a more higher prices. So, it depends on what kind of users are there. Okay. So, there are certain relaxations and when you are looking at as an academic and a public sector. Okay. So, when you look at data pricing, you have high data pricing versus a low data pricing. High data pricing, it will actually help encourage the user to compile data on their own. Basically, that is exactly what users of today are trying to do. There are a lot of data that is available which is actually proprietary data. If you have to buy any of those data, you have to pay a large amount upfront. So, instead of that, it is better to develop our own data. That is what people are trying to do. If you, let us say, and more importantly, it reduces the importance of any public sector or a data producer. Okay. That is why many of those companies which are commercially putting out the data may not be well known, because the data are extremely costly, which cannot be accessed by the maybe a public agency or from our academic or a general public. If you, let us say, in that context, if you have a low data policy, data pricing policy, so it brings difficulty in data updation due to cost recovery failures. So, you have your data has to be updated every now and then. So, it has to have certain values. So, if you have a cost that is actually very less in terms, many of the government agencies today charge extremely less for the data cost. So, if that is the case, then it may not be feasible in updating the data. That is why most of the government data is outdated. So, if you really have to update, so your pricing should be competitive enough, but not very high. Okay. And the value of quality data is not appreciated. So, that is why if it is a low data, especially when you are looking at the Indian data, so the value of quality data is not appreciated if it is a low price data. Okay. Then there are cost recovery, different cost recovery methods when you are looking at enforcement of copyrights in states of United Kingdom and Netherlands. They facilitate 70 to 80% and 30 to 40% of cost recovery rates that are available in those countries. However, if you look at USA, the cost recovery rates for any data is 100%. Always, whatever data is produced by them by different agencies is 100% consumed. So, they do not have any loss. But when you look at Indian scenario, as per certain reports, we have somewhere a marginal cost about 6 to 8% recovery. So, that is where the Indian data, or in Indian context, the data is not very much publicly available, or it is not utilized in a larger context. They consider some data have to be more social significance than the of commercial interest in when you are looking at US data. Data such as accident data, data for military use may have little or no recovery at all. So, those should not be in this pricing bracket. So, keep that in mind. So, as an economic point of view, you should have a marginal cost of production, distribution cost, percentage increment to cover some fixed cost of production and the risk associated. So, all of this put in together may be your digital data charge, which should be quite marginal. Okay. When you are looking at public or a private organization of a geodata, the public or a private organization of geodata will require production or supply depending on prevailing market conditions. So, it cannot everything is decided on the market condition, either on standardization of data products by the producer or homogenization of the market. So, depending on all of these, the public or the private organization of geodata will be required to produce or supply the demand of the data. And when you look at demand and supply mechanics of geodata, it is basically a business approach. Okay. So, you should look at supplement basic data with the standard data if it is possible, and distribute the combination as a standard package to all users. So, that is what most of the public companies do it till now. So, or supplement basic data with other standard data to compile a tailor made basic data. So, this is what the private companies do till now, or any of those companies which are providing data. Supplement basic data with user specified data to compile tailor made user product is what most of the enterprising companies do till now. So, all of these are different ways of business approaches that you can do. Okay. So, it depends on a particular company and a particular user to choose what kind of data and how, from which source that particular data is considered. And the final part is data security. So, different countries have its own regulations. So, once the data is crossing the boundary, it is bound to define that particular country's data regulation. So, in USA, the Financial Services Modernization Acts permit organization to acquire, distribute substantial personal information unless an individual specifically has to be removed from registry. Okay. Sensitive data such as maps or border areas, disputed territories, endangered species, rare plants are considered to be of national interest and restricted accordingly. You can see such restrictions even in India. There is a national data registry which can be flexibly used as one of those security tools. And when you are looking at data security, you can find out a huge amount of security concerns or rules that have been put forth in terms of data productions. And in some cases, limited information is openly available, and combining data from open registers may be considered to be an registry and security risk. So, be careful with this. In future, it is recommended to share data in a coded format to avoid tampering. So, this is what now the GIS companies are actually looking at. So, they are coding out all the GIS data, and so that they avoid any tampering of data or misrepresentation of the data. Okay. So, this is about today's class. We looked at network operations, we looked at proximity operations, finally different types of interpolations. Then we looked at DTM, DSM. I have spoke about tin and contour, so I did not look at it much, but it is also comes under the advanced data models. So, if someone is interested, please look at how the expert system work, how the artificial intelligence can be clubbed with GIS for performing advanced analysis. Then probably you can look at fuzzy analysis and other systems that are available. So, that is what is advanced GIS. Then we looked at data limitations in usage, how it can be used, and finally we ended it with data security. So, data security is extremely important in context of data production and data usage. So, that is the first and the foremost thing that any data user or any GIS user should look at it when you are looking at context of producing or distributing data. Okay. So, let us meet in the next class. So, next probably 2 weeks or 2.5 weeks will be completely looking at hands on. So, we would be using QGIS software. So, people who have not downloaded QGIS software, please download it now. So, in the next 2 weeks we will be completely giving you how that particular software is organized, what are different operations that can be done on those softwares, how to use a raster data, how to use a vector data, how do you develop a thematic map, what kind of maps that you can prepare, how do you actually present a map to the user, how do you develop a final map, and probably looking at different aspects of it. Maybe I will give you some examples of interpolations, etc. my TAs would actually accompany me in looking at all of these aspects as a practical sessions. So, till then, have a nice time. So, please download QGIS and install it. So, let us meet in the next class. Thank you very much.